Welcome back to Demolition Worker. Today we dive into sophisticated salvage, exploring the incredible microengineering hidden inside massive commercial airplanes. This episode focuses entirely on the microscopic details of aviation technology. We will dismantle the most critical flight sensors and recorders. Look closely at the nose of this retired aircraft. This area houses the vital instruments that keep the massive plane flying safely. Our first target is the pitot tube. This small, protruding metal device measures airspeed by capturing the dynamic pressure of rushing wind. Removing these tubes requires exceptional care. We carefully unscrew the mounting bolts, ensuring we do not damage the delicate internal heating elements. Inside the pitot tube, powerful heaters prevent dangerous ice formation at high altitudes. These heating coils contain valuable aerospace-grade conductive alloys. Notice the intricate wiring connecting the tube to the main computer. Every single wire is shielded to prevent electrical interference during flight. Next, we move to the angle of attack sensor. This rotating vane tells the flight computer the exact pitch of the aircraft. Extracting this sensor is like performing mechanical surgery. We must bypass the heavy exterior rivets to reach the sensitive calibration mechanisms inside. The internal bearings of this sensor are incredibly smooth. They are manufactured with extreme precision to ensure absolutely zero friction during operation. We carefully disconnect the sensor housing from the fuselage. The aerospace aluminum used here is highly sought after in the recycling market. Inside the sensor, we find small circuit boards. These boards are plated with premium quality silver to guarantee perfect signal transmission always. Now we proceed to the avionics bay beneath cockpit. This dark compartment serves as the electronic brain of the entire airplane. Thick bundles of colorful wires run through this space like veins. We must navigate this complex maze to find our ultimate prize. Deep within the aircraft tail section, we locate the flight data recorders. These are universally known to the public as black boxes. Despite their famous name, these crucial devices are painted bright international orange. This vibrant color ensures they are easily visible after accidents. Reflective tape covers the exterior of the heavy casing. This tape helps search teams spot the recorder underwater or in debris. We carefully detach the heavy mounting brackets. The sheer weight of this small orange cylinder reveals the massive amount of protective armor. Attached to the front is the underwater locator beacon. This tiny silver cylinder sends acoustic pings for 30 days if submerged underwater. We bring the heavy flight recorder back to our specialized workshop. It is time to see exactly what makes this device indestructible. The outer shell is constructed from incredibly thick titanium or stainless steel. This armor is designed to withstand massive, catastrophic impact forces. To demonstrate its legendary strength, we place the outer casing inside a hydraulic mini press. Let us see the pressure it takes. We slowly increase the hydraulic pressure on the steel shell. The gauge climbs rapidly, but the orange casing refuses to bend easily. Even under thousands of pounds of direct force, the shell only suffers a minor dent. This engineering is truly a modern marvel. Now, we use specialized industrial cutting tools to slice through the outer armor. Sparks fly as the diamond blade grinds against titanium. Breaching the first layer reveals a thick block of dry silica insulation. This material protects the data from intense, long-lasting fires. We carefully chip away the white thermal insulation. It is a messy process, but it is necessary to reach the precious core. Beneath the insulation lies another protective barrier. This is a heavy stainless steel inner shell that guards the memory boards from crushing. We unscrew the heavy bolts securing the inner casing. Every single layer of this device is engineered for absolute uncompromising data survival. Finally, we expose the crash survivable memory unit. This small, dense block contains all the critical flight data and voice recordings. We gently pry open the memory unit housing. Inside, we find a stack of highly specialized, heat-resistant solid-state memory boards. These specific memory chips can survive temperatures exceeding 2,000 degrees Fahrenheit. They are the most resilient electronic components ever manufactured today. Holding these chips feels like holding the true brain of the airplane. This is where the most sophisticated microengineering is displayed. We carefully detach the memory ribbon cables. The connectors are heavily plated in gold to prevent any corrosion over many decades. Now we gather all the extracted sensors and circuit boards. It is time to begin the delicate process of precious metal recovery. We set up our precision workbench with specialized lighting. This phase of the salvage operation requires the steady hands of a jeweler. First, we examine the angle of attack sensor boards under a microscope. The tiny contact points are rich in valuable silver alloys. Using micro clippers, we carefully snip the silver contacts from the green fiberglass board. Every tiny piece is collected in glass vials. Next, we focus on the main processor chips from the flight computer. These large ceramic chips contain a significant amount of gold. We apply a gentle heat gun to loosen the strong industrial solder. The ceramic chips slide perfectly off the thick circuit board. Inside these processors, microscopic gold wires connect the silicon die to the external pins. This gold is exceptionally pure and highly valuable. We move on to the communication interface modules. These specific components often utilize palladium to ensure stable radio signal transmission capabilities. Extracting palladium requires identifying the specific monolithic ceramic capacitors. These tiny rectangles are carefully desoldered and sorted into a separate, clean container. The sheer volume of copper wiring inside the sensor housings is astounding. We strip the tough Teflon insulation to reveal shining copper. We bundle the high-grade Aerospace copper wire together. This pure copper is highly conductive and commands a premium market price. Let us take a closer look at the pitot tube heating element. The internal resistance wire is made of special nickel chromium. We extract the shiny heating coils using needle nose pliers. While not a precious metal, this industrial alloy is highly valuable today. Returning to the black box memory boards, we carefully remove the protective conformal coating. This clear resin layer blocks extreme moisture. We use a specialized chemical solvent to dissolve the tough resin. This exposes the beautiful gold-plated traces running across the board. Using a fine scalpel, we scrape the valuable gold plating from the connection edges. The shiny flakes fall into our collection tray. The precision required here is absolutely incredible. One wrong move could send the microscopic precious metal flakes scattering far and wide. We inspect the heavy steel casing of the black box again. Even as scrap metal, this premium steel holds significant value today. We toss the heavy metal chunks into a recycling bin. Every single part of this sophisticated machine will find new purpose. Next, we dismantle the underwater locator beacon. This small device contains a specialized lithium battery that must be handled with caution. We carefully extract the battery cylinder and place it in a safe disposal container. Environmental safety is always our top priority here. Inside the beacon, a small piezoelectric crystal generates the acoustic ping. We extract this fascinating component for our personal oddity collection. We now sort the collected materials into distinct piles. We have copper, silver, gold, palladium, and high-grade aerospace aluminum ready today. The pile of gold-bearing components is surprisingly large today. These old aviation computers were built with generous amounts of precious metals. We weigh the extracted silver contacts on a highly sensitive digital scale. The final number proves that this meticulous work is profitable. The palladium capacitors are also weighed carefully. Palladium is currently one of the most expensive industrial metals in the entire world. We package the precious metal components into secure shipping bags. They will be sent to a specialized refinery for final chemical extraction. Looking at the empty, dismantled shells of the sensors, it is amazing to think about the countless flights they safely guided home. These instruments endured freezing altitudes, scorching heat, and massive turbulence. Now their journey ends quietly on our brightly lit salvage workbench today. The black box casing sits empty and defeated. It survived decades of flying, but finally met its match in our demolition shop. We sweep the workbench clean, ensuring no tiny fragment of valuable metal is left behind. Every single gram truly matters in salvage. The process of dismantling microelectronics is drastically different from tearing down a fuselage. It requires endless patience and sharp eyes. We take a moment to appreciate the brilliant engineers who designed these systems. Their work ensured the absolute safety of millions worldwide. The complexity of a single angle of attack sensor is mind-blowing. It is a perfect symphony of mechanical and electrical design. Even the simple pitot tube is a masterpiece of thermodynamics. Its ability to melt ice instantly at freezing altitudes is truly remarkable. As we pack up our specialized tools, we reflect on today's unique harvest. We have successfully extracted the hidden wealth of aviation. The heavy hydraulic press is powered down for the day. It did a fantastic job testing the legendary strength of the recorder. We store the titanium armor pieces in our scrap metal container. They will eventually be melted down and forged into something new. The bright orange paint on the black box fragment still catches the light. It remains a powerful symbol of aviation safety standards. We organize our collection vials filled with tiny silver and gold components. They look like colorful treasure chests from a modern pirate. Tomorrow, we will tackle a completely different section of the aircraft. But today was all about celebrating sophisticated microengineering and salvage. The contrast between massive jet engines and these microscopic memory chips is fascinating. Both are equally important for a safe, successful flight. We carefully label each bag of salvaged electronic components. Proper organization ensures we get the best possible price from the metal refinery. The heavy steel workbench bears the scratches of today's intense labor. Tearing apart indestructible objects is never an easy or gentle task. We inspect the cutting blades used on the titanium shell. The tough aerospace metal has significantly dulled our best industrial diamond tools. Replacing these specialized cutting tools is just part of the business. The high value of the extracted precious metals easily covers costs. We take a final look at the dismantled crash survivable memory unit. Its impenetrable fortress has finally been breached and completely emptied. The dry silica insulation dust is swept away from the floor. We maintain a clean workspace to ensure safety and maximum efficiency. We secure the hazardous waste containers holding the lithium batteries. Proper disposal protects the environment from dangerous, toxic chemical leaks and fires. The bright lights of the workshop reflect off the polished aluminum scraps. It is a highly satisfying conclusion to a challenging day. We log the total weight of today's recovered materials into our database. Tracking our daily progress helps optimize our future salvage operations. The palladium capacitors alone make this specific salvage operation incredibly worthwhile. Their tiny size hides their massive economic value in today's market. We lock up the secure cabinet containing the precious metal vials. Security is paramount when dealing with such concentrated high-value materials. The dismantled airplane outside sits a little lighter tonight. We have successfully removed its electronic brain and highly sensitive nervous system. Every wire cut and every bolt removed tells a story of technological progress. We are simply the final chapter in that story. We power down the bright inspection microscopes and precision soldering stations. The delicate jeweler work is officially completed for this specific episode. The contrast of heavy demolition and delicate micro-extraction makes this job amazing. We get to experience the absolute extremes of labor. We hope you enjoyed this deep dive into the microscopic world of aviation. It is a hidden realm most people never see. The engineering behind these vital flight sensors is nothing short of miraculous. They represent the absolute pinnacle of modern human technological achievement. Thank you for joining us on this incredible journey of sophisticated salvage. We love sharing these unique mechanical discoveries with our audience. Remember to like and subscribe if you want to see more teardowns. We have plenty of massive aerospace machines left today. Next time, we will explore the massive hydraulic landing gear systems. Get ready for some serious heavy lifting and massive industrial wrenches. This has been Demolition Worker, signing off for now. Stay safe, stay curious, and we will see you in the next video.